your host now. Okay. So see, for this problem, first we have decided the maximum dimensions, length, height, and the width. Looking from this end, this dimension that 35 becomes your length, and the height by addition of these measurements of height of these steps. First step, this one 15 millimeter. Second one, that is a C surface, that is 15, and this E surface, that height is 10 millimeter. So in total height is becoming the 40 millimeter. Okay, that we have marked here 40 millimeter, right? This 15 plus 15 plus 10, 40. Length, this one 35. Then the height, width, third dimension is the width. Okay, so we have taken this dimension length and this height. Then the only remaining dimension is this one. So measurement is not given here. Okay, instead of that, this 15, it is in part 15 plus 20 plus 20. So 15 plus 20 plus 20, that total becomes 55. Second step is to decide the position of views. Obviously, front view and top view will be coming accordingly with respect to XY line, above XY line, front view, below XY line, top view. Now, you will in first angle projection method. In this case, this is the position through which you can look at the object to get your side view. Okay. So, if you're looking from the left side, that left hand side view appears on right side of your front view. Means with this we have got the judgment, we have got the uh, orientation of views with respect to xy line. Okay, so accordingly what we have done, we have completed the boundaries. First of all, we have drawn the xy line, then about 10 xy line by 10 millimeter, below xy line by 10 millimeter we have drawn two lines parallel to xy line. Okay. Then selecting any one point here, from where we have taken the length 35. This is 35 length. Then from here we have taken the height 40, and we got the rectangle 35 by 40. This rectangle complete. This is nothing but the boundary of your front view. Then for top view, we need two dimensions. For top view, this width and this length, these two dimensions will be in picture for top view. So length 35 that we have projected by taking the projection. See, your title of your topic is orthographic projection, means you have to complete the answer by taking the projections from views. Okay, for front view, top view, some dimensions you will be taking from the front view. For side view, you will be taking the length and width and the height from width from the top view and height from the front view. Okay, so for top view, two dimensions. So length already we have taken here 35. Then we have added this width, that is 55 as per this problem. So this 55 we have taken here, right? Then we have projected this width to this 45-degree inclined line where this xy, x1, y1 and xy line intersect. We can say O point. Okay, this xy line and x1 y1 line where it intersect, we say it's a x1 and y1 line. Okay, where it intersect, through which we have taken this 45-degree, and the extreme dimensions, that is width from one end point, this one we have projected, it is touching x 45-degree line here. Then the next point we have taken it from here. I will show you. Okay, I will take it in a window so you can see it. Okay, so here see, this also we have projected and it is touching xy line 45-degree line here. Okay, and then we have taken this vertical projection from both the points, both the extreme points, we have taken it vertical. So what is going to happen by with this 45-degree line, this 55, if you project it and if you
55.
take it later on, if you measure it, you will find 45 only. No, sorry, 55 only. If this width is 55. If you project it, surely you will get 55 only. You can cross check that. Okay, even then the height base point we have projected, and the top point we have projected where it intersect with these two vertical lines, and that will give the boundary for your side view, correct? So in this way we have got the boundaries for front view. This boundary is for front view, this rectangle is for top view, and this one more rectangle. Sometimes you will get even square if the dimensions are um, width and height are equal. Okay, so this is what the third step, getting the boundaries mark for front view, top view, and the side view. And then we'll start with the actual views by looking at the object. Okay, so when you're looking from this end, then at the base this line is visible, so we have completed this line, dark line. Then this height for 15, and then again the length 35. So this height two lines, and then the length line for this surface, this edge that we have drawn. Okay, now the next, after this, once we complete that surface A, which surface is visible to you from this end? Only this front surfaces visible from this end, that is the C and the E. For C, again C, this edge and this edge is going to be the single edge. It is going to overlap each other. Okay, because this is on the same plane. As far as the planes are concerned with respect to baseline, this is the line which is going to overlap with this. So obviously this line is already there. Then we have to mark this 15 plus 15 on 15 both side. Okay, so we'll take the 15. We'll mark the point here. Again, we'll mark the point on this side also. Otherwise, with the roller scale, roll and draw, you can get the line easily without taking the points. Okay, anyhow you will get the point here 15. So I will make it with the pen. Actually you have to do your drawings by using pencils only, whether it lead pencil or the uh, conventional pencil. So you will get the surface C here. Okay, so this is visible. Then the next one, 10 millimeter height. So remain dimension is 10. So you need not have a measurement further, and you can complete this by making the lines dark, because all those lines are visible. This is what the line which you are drawn here. Okay, so I will write here just for your information. You need not do it in exam, like you have you need not name the surfaces A, C and E surface here. Okay, so this is the complete front view. Then we have to look at the top view. See, in top view, along this width of 55 millimeter, this first surface, that is F surface, from this end, you should not get confused with F surface, whether you will be taking on this side. No, left side, kahan se you will be looking from this end for the top view. Okay, and the extreme end of this width is this one, first one, top one. So you'll be taking this 20. So I will take the marking for this 20 first, this 20. Then again, D surface is for 20, and the third surface is 15 millimeters. So obviously it will be coming like this. Okay, you look at the surface, you will find that it is found in length 35 and width 20. So length 35 is already here, and then width 20. So you can get that rectangle here. This is a rectangular surface F. So we'll get, so this edge is visible. This is nothing but the edge, this one. Second edge is this. So this is visible but you can take it with the roll and drop from here. So this edge, again for F surface, these two edges are visible. So we'll make those edges dark. As I said, you will be not using pen at all for any of the edge drawing. Okay. But just for visibility clarity, I am doing it by using pen. So it will be comfortably seen at your end. Okay. So this is what the surface F. So these are the very basic simple problems which I am taking in the beginning so that you will understand the basics of orthographic projection. Later on, we will maybe from tomorrow we will take the little complicated problems. Okay. Then the surface is D. C. This edge of F surface and this edge of D surface, it is going to overlap. When looking from the top, this edge and this edge will be the single edge. So this is the edge which is already got here. So what we'll do, again, width 20 millimeter, we'll get one more edge here, and this you can complete because side edges are visible along width. These two edges are visible. This edge and this edge is visible, so we will make it dark. Okay. So this is what the surface you will see here, the surface D. And again, one more surface is visible from the top, is nothing but the B surface, that is of 15 millimeter in width and in length 35. So this remain is 15 and this width already there. So you can even make it further dark. Okay. I am explaining in a segment or the stages so that you can understand this. Once you will get the concept, then in a minimum possible time you can do it. So this is what the surface B means. In top view you will get this one. In front view, whatever the edges and the in terms of length and the height, and here the in terms of length and the width. Okay.
Sir,
Then
I had a doubt.
yes,
Sir, how do we decide what view comes where?
see, this is the width, right? This is the width which you have taken 55. Okay. This is the length which you are for front view. Which two dimensions are visible to you? Let me know. Tell me. Apart from this length, height, and width, which two dimensions will be seen in front view?
The height and the width.
No. How you can see the height and width? You if you see, if you are looking at the building from front side, okay, in which two dimensions will be applicable in that case? If you are looking at the building or
35
anyone
and 55.
in front view,
Oh no, 35 and 40. Yes, 35 and 40.
yes, mean that is nothing but the length and the height is visual, right?
Yes, sir.
Oh, that's why. So length that will be along the x-axis, and perpendicular to that, that will be the height, right?
Yes, sir. But my question was, how do you decide what view comes where on the XY plane? As in when we draw the all the views.
See, this is the second step which I have explained. Front view that will be coming above xy line, right? Any doubt with this?
Yes, sir. This one.
Front view above xy line. Have attended the very first lecture of on orthographic projection.
I have, sir, but I missed bits and pieces of the
So,
lecture because
so
of some
yeah,
internet
yeah,
issue.
not an issue, not an issue. Okay, you have to wait. Let me complete this. Okay. Mm, then once the recording will be over, then I will explain all those things again. Okay, not an issue. Okay, you have to wait
Okay,
for
sir.
some. See, the front view we completed, top view we completed, then side view. If you looking from this end, this edge is visible, this edge is visible, then this vertical edge, then horizontal edge, then vertical, then. But here in orthographic projection, you are not supposed to complete it by separately. You have to take the projections from the top view. So I will extend the additional edge which appears in top view here. So I will be taking this edge here. I will project it. I will be projecting from here also. Okay, and then I will be taking it vertically. What I will do, I will go vertical, and you have to do like this only. This is the very simple problem. So even though without this also you can do it, but you follow the basic principle of orthographic projections. Okay. Now you will be taking the horizontal projection from this front view. Let me take this throughout its width. Okay. See, this is what you are getting this. Now, when you're looking from this end, this top surface is visible, right? But for this 20 in top view, this 20 you are getting hit straight away directly. This vertical height for side view, this 10, you are getting this 10 from here. So what you can do from side view, you can see this edge, this edge. What I will do here, I will be drawing this vertical edge completely in a one go. This is visible, right? This bottom edge is also visible throughout its width. Then in a segment for front side view, this edge is visible up to this length. At a height of 40, I'm going to see this edge. Then this edge is visible, so that I will taking it because I have taken the projection vertical from here and horizontal from the top view. So I will be getting this line here. You can see this edge. Okay. Then what happens for D surface? This edge for 20 millimeter length is visible, and this 20 already we have taken it from here. So what we'll do, we'll be drawing this as well. Okay. Then again, this edge for 15 millimeter down, I will be taking it from this. Then for B surface, this is for again 15 millimeter here. So this 15 millimeter is already available here. When you have measurement of this, you will come to know that. Okay. And then finally, this vertical edge, which is common for this A and G, that is visible, and I will make it dark. Okay. So this is what your complete in this way your answer of for side view completed. I will make it little dark. I think it is not. So this is what the line which you have projected. So this we have projected from front view, and from the side view, sorry, top view, these edges are visible, right? So the dark line is in terms of this vertical and the horizontal edges, you will get your. Now you can give the dimensions for this. So for the dimensions, what you have to do, you have to have a extension of dimension lines from each surface to mention your dimensions, and then you can have a dimension line here keeping safe distance big, okay, but with limitation of space with here, we'll be taking it little close. You will be drawing the arrows. So this 15, this again 15. I will write here by pen 15. This is 15 and this is 10, right? Similarly, in width, I will extend for dimension purpose. Again, with some distance, I will be showing the arrows. I will be sending the clear image of this after lecture. So this is 20, 20, and then this is 15. Okay. So in side view, all dimensions are going to get from this front view and the top view. So you need not mention any dimensions here. Okay. Automatically, you are coming to know the dimensions in terms of this width and the height here. Okay. Rujuta, you can stop here.
Yes, sir.